Now we're in part 3 of our review for test 2. We'll continue on with our chapter 5 questions in numbers 4, 5, and 6 on this page. It says the probability of drawing a blue cube from a hat is 80%. What is the probability of drawing 4 blue cubes in a row, and each cube is replaced after being drawn? You need to go back and watch one of our old videos from chapter 5 about teachers being satisfied with their careers. It's very similar to this problem. It'll be immensely helpful for our next test. So essentially I want the probability of a blue cube, then a blue cube, then a blue cube, and then a blue cube. So 4 blues in a row. The probability of the first cube is blue is 0.80, that's 80%. And we have independence here. Because these cubes are replaced, there's always the same number total in this hat, and there's always the same number of blues in this hat. So if you replace the cube after it's drawn, there are always 80% of your cubes that are blue. So the second cube also has a 0.80 probability. The third cube has a 0.80 probability of being blue, and so does the fourth cube. So 0.80 times 0.80 times 0.80 times 0.80 is 0.4096. You could also say this is 0.80 raised to the fourth power to get that 0.4096. Number 5 is directly related to this question. It says the probability of drawing a blue cube from a hat is 80%. Now we want to know what is the probability that at least one cube is blue. Now, at least one gives me multiple possibilities. There could be 1, 2, 3, or even all 4 cubes that are blue. At least one means that number and more. Rather than calculate all of these, it's more efficient to use the complement. The complementary event to all of these would be that you get no blues. Don't worry about having to get 1 blue because you don't know if it's first, second, third, or fourth. Then 2 blues, 3 blues, or 4 blues. Just worry about getting no blues and then use the complement that we saw in chapter 5. So the probability of no blues is 0.20 times 0.20 times 0.20 times 0.20. This is because if 80% of the cubes are blue, that means 20% or 0.20 are not blue. That's the complement. So the first cube has a 20% chance of not being blue. It's replaced. The second cube has a 20% chance of being some other color than blue. Same for the third and the fourth. So you could say 0.20 raised to the fourth gives us 0.0016. So the probability of all these other events, the 1, 2, 3, or all 4 blue, probability of at least 1 blue is calculated as 1 minus, you get no blue, so 1 minus 0.0016 is 0.9984. When we see this at least one wording, the complement is probably a very good idea. Final one, number 6, and this will wrap up what we need to know for chapter 5 for test 2. We're going to calculate some probabilities based off of a two-way table. Here my categories are: did the person in the store purchase insulation for the roof, or did they not make a purchase? Then, what kind of roof did the person have? Were they a customer with a 30-year roof in good condition, those with a 20-year roof in good condition, or those who needed a new roof? A says, what is the probability a customer purchased insulation and needed a new roof? And is a keyword that means overlap. I want to see where do these categories overlap. So purchased insulation is this row. Needed a new roof is this column, and they overlap at 4. So my probability of purchasing insulation and needing a new roof is 4 people out of 230 total. If you divide that, you get 0.0174, and means overlap. Second part asks, are these events independent? Well, in order for the events to be independent, there's a formula you need to know, and this formula was discussed in a previous video. A and B are independent if the probability of A equals the probability of A given B. So the probability of A is just the probability of your first event occurring, no conditions put on it. So in this case, let me call A someone who purchased insulation and B someone who needed a new roof. So I want to know what's the probability of A, what's the probability that somebody purchased insulation? Well, a total of 17 people out of 230 purchased insulation. That would be 0.0739. For the second half, probability of A given B, that's the probability someone purchased insulation given they needed a new roof. So I'm only looking at those that needed a new roof. I'm only looking at these 98 people. Out of these 98, 4 purchased insulation. So 4 divided by 98, that's 0.048, and these are not equal probabilities. So since they're not equal, they are not independent, but they are dependent. The shape your roof is in will determine whether or not you purchase insulation. And this is something you'll need to do for our next test. On part B, we have an or probability. It says, what is the probability a customer purchased insulation or needed a new roof? So the same two characteristics, but instead of and, it's an or. So or means add. I'm going to look at those who purchased insulation, which is a total of 17. Those that needed a new roof, which was 98. But note these overlap. We already know they overlap from the previous question. They overlap at 4. 4 is being counted twice. To get this 17, we took 8 plus 5 plus 4. That gave us the 17. To get this 98, it was 4 plus 94. So to get my top number, I would say the 17 who purchased insulation plus the 98 who needed a new roof minus the overlap that's being counted twice. That's 111. So it would be 111 out of 230. If I divide those, it's 0.4826. To answer the question, are these mutually exclusive? Because these events overlap, they are not mutually exclusive. In order to be mutually exclusive, you can't be in both categories at the same time. There are 4 people who both purchased insulation and needed a new roof. They are not mutually exclusive. C is another or probability question. What is the probability a customer had a 30-year roof or a 20-year roof? Here are my 30-year roof people. Here are my 20-year roof people. Note that they don't overlap. Either you have a 30-year roof or a 20-year roof. Or means add, so I take my 50 plus my 82, those totals. That gives me 132. I'll divide that by 230, and that gives me 0.5739. Now, these do not overlap. You can't be in both categories at the same time. Therefore, these are mutually exclusive. Final question from this video. What is the probability a customer did not purchase insulation given he or she had a 20-year roof? Note in this problem, you have 2 categories: not purchasing insulation and having a 20-year roof. But there's no and at all in the wording. You're not looking at the overlap of those 2. There's no or anywhere in the wording. So you're not going to add. The key word here is given. You are given the person had a 20-year roof. This is a conditional probability. We're not looking at all 230. We're only looking at those who had a 20-year roof. We want to know, out of those 82, how many did not purchase insulation? Well, there would be 77. 77 divided by 82 is 0.9390. We don't classify this as independent or dependent. We don't classify this as mutually exclusive or non-mutually exclusive. There is no classification here.